anyone in the industry understands demand is soft. We've lost a major market. The economy is bad. The debt markets are poor now that I've depressed everyone over their breakfast. What this is doing is it has the effect of driving the market is driving crystalline prices significantly downward, which is giving pressure to thin film prices. If this situation continues, which it likely will at least for the next year, how will thin films compete? And since y'all are selling turnkey lines into this industry, what are you telling your customers?
You're right, the dynamics this year is a very challenging one. The prices for all technologies are down, both thin film and crystalline. I'd say the longer term positive trend is that the expectations of PV prices are being set significantly lower. I think all expectations are that the pace of growth is going to return in the market. And so we're seeing continued interest in entering the market for thin film manufacturing. I think it underscores the importance of our delivering on our technology roadmap. If it was not clear before, it's certainly clear now that our customers' ability to produce thin film at significantly less than $1 per watt becomes an imperative to participate in the market.
So I'll echo a lot of the same sentiments that Chris brought up. I think from an applied perspective and our customers, our real focus area is driving cost per watt differentiation. I firmly believe that we will be able to differentiate significantly on the cost structure between a crystalline silicon module and a thin film silicon module. I think there's two other areas that we're focused in that should also help in terms of thin film silicon demand. One of them is downstream. So we're actually putting a lot of effort into working with utilities, the end customers of our customers, to understand what their requirements are and how we can put factories into locations that create green jobs, take advantage of the subsidies and so forth that the various governments are putting into place to really drive growth. We're also working with our customers to understand bankability concerns, which is certainly an issue right now for new technologies in general, and this includes thin film silicon, where we're trying to understand barriers to entry in terms of project financing, risks associated with thin film technology, and so forth. And then the third area, I'd say, between the cost, understanding the downstream, is government policy. So we're really spending a lot of time there to make sure that we shape policy to grow thin film silicon demand.
The key issue is how amorphous thin film is going to compete with the First Solars of this world. So I want to understand how you're going to compete with that. And obviously the efficiency levels for amorphous have not kept track with those of First Solar.
First, all thin film silicons are not alike. What we do is combine add on to the back of a amorphous silicon layer a second silicon layer of microcrystalline, which we trademarked as micromorph. And what that does is to boost the efficiency by about 50% compared to a single junction. We further have incorporated in our manufacturing process the deposition of what's called the TCO, the transparent conducting oxide on front and back contacts. That gives us an important tool to optimize the efficiency of the device. What the net effect is that we're currently guaranteeing customers about 9.3% of aperture efficiency for modules that are produced with equipment they buy today, and recently demonstrated an initial efficiency of 11%, which stabilizes about 9.6% for full-size modules, a set of full-size modules coming off our pilot line in Trupach. So thin film silicon is narrowing that gap, that efficiency gap. Still, First Solar is still leading. I think that there's an important difference between the vertical integration strategy that First Solar is pursuing in the U.S. And the strategy that we're pursuing, which is to try to ramp up a technology across a fleet of customers. So we currently have 10 customers with total cumulative capacity of signed contracts of about 600 megawatts. First Solar is approaching a gigawatt in capacity after many years in operation. So we're getting to scale very quickly.
Although their absolute efficiency is higher than thin film silicon today, or what's in production, I think at least both cases, Oerlikon and us, we've significantly closed that gap, and from a if you plotted the efficiency improvement over time, we're on a much higher trajectory than First Solar is. So we're right now in the lab demonstrating 10% stable modules, mini modules. We have the utmost confidence we're going to be able to transfer those processes to the large form factor. And we really believe that we are going to pass First Solar in terms of efficiency improvement and therefore be able to have a very competitive cost structure. The second aspect is again on the balance of system side. So I believe that the large form factor has an inherent advantage. Typically we've stated that a 9% full size panel will have a comparable cost structure from a BOS to an 11% First Solar module. And so as we close that gap or exceed them in terms of efficiency, I believe the overall installed system cost will surpass or be below what First Solar can produce.
Let me make a statement about thin film and the market we, the industry, not just us as a company, are addressing. So basically in Europe and the USA, which are for the midterm future, the major markets for PV, we have a segmentation in 3 customer groups, which is residential, commercial roofs and field installations. And thin film in general clearly is not targeting the residential market, because we need more space, we have less efficiency, but better energy harvest. So it's a very good product for commercial roofs and field installations. And the only thing which counts in this market segment is return on investment for the investor or for the utility company. That means we need to offer a system to the end customer or the investor which is more efficient in terms of kilowatt hours per kilowatt peak installed or in terms of dollars per dollar invested. A couple of years ago, only customized equipment was available on the market. So we really appreciated that Oerlikon and Applied entered into the market with, let's not name it turnkey, with complete production lines, which enables companies to set up a line without really large own engineering efforts. And this enables the PV thin film industry to grow to larger volume. We as the industry really need the help of the equipment companies to get material costs down. We need the help of the material companies, such as Linde or glass suppliers, foil suppliers to get the costs down. And this cost sector amounts to about 65% of the entire cost. And then we are absolutely certain that it won't take long to go below $1 per watt in production cost.
I mean, from our point of view, we've observed this, rush towards the gigawatt scale. And actually, the larger the scale does become, the greater the levers there are available to really make a meaningful impact on the materials. So the gigawatt thing, we saw it last year. We engaged with it. We saw it pull back this year. But just as Chris said, it's very difficult to believe if the industry is going to live up to the aspirations that we're seeing, that it will not come back. So, I mean, I kind of view this as a very nice pause for breath, a chance for your customers and us with your customers to figure out some of the issues that there are around even just the supply of these materials and making these lines work. And ultimately, I think it'll be to the benefit, because when the time comes for the ramp up of these really huge facilities, then it isn't going to be done on 36 or 48 months, because I think actually by then the industry will be ready to do it in the 1 to 2 year time frame.
I agree with Chris in the believing in the fundamental demand drivers. I mean, the global warming problem isn't going away. Clean energy is a priority for everybody. And some calculations I did a while ago said that if we wanted to get to just 1% of electricity production in the world, just 1% or 1.5% by 2020, the cumulative production capacity for PV would have to be something like about 60 to 70 gigawatts per year. But if you free the demand from the constraint and really drive towards 1%, if the cost structure allows you to drive to 1%, then the production capacity in it is huge. And there's room for all kinds of technologies to fill 80 gigawatts, whether it's silicon or SIGs or crystalline silicon, all of it, right? So I think we shouldn't be myopic in thinking about like we're looking at a demand of 5 gigawatts a year. But really, what is the real demand? What does 1% of power represent? That's the demand, I think. And I think once the capital constraints are removed and once the cost structure brings it down to, and the other thing I keep looking at is look at wind. I mean, 10 years ago, wind was less than like 1%. Right now in the US alone, it's like 4% or something like that. It can grow.